at the addition rule for probability. Now, addition rule is that the A union B is equal to the probability of A plus the probability of B, take away the probability of A and B. So the probability of, we can also say that as A or B. Now we can use a Venn diagram to do this. So we've got the scenario of the numbers from 1 to 12. We've got the set A is the even numbers. So I'm going to draw up my first one. So my even numbers are going to go in A and my multiples of 3 are going to go in B. Now my even numbers are going to be 2, 4, 6, 8, 10, 12. My multiples of 3 are going to be 3, 6, 9, 12. So my overlap is the 12 and the 6. So they will go in the middle. Then in the first one, I've got 2, 4, 8, 10. And in the second one, I've got 3 and 9. Then I need to put the ones outside, which are going to be 1. Then I've got 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. So I've got those 4 numbers outside. I can then draw that with, instead of the list of items or elements, I can just put how many. So I've got 1, 2, 3, 4 outside. I've got 1, 2, 3, 4 here. I've got 2 in the overlap, and I've got 2 there. So I can then find the probability of A union B. I know I've got 12 numbers altogether, so it's going to be over 12. And I've got 4 plus 2 is 6 plus 2 is 8. And that becomes, if I divide by 4, I get 2 over 3. So I've got my probability of 2 over 3. If I used my addition rule, I would need to know a few things. So my probability of an even number is 1, 2, 3, 4, 5, 6 over 12 for my probability. My probability of a multiple of 3 is 4 over 12. And then the probability of A and B, so that's where I multiply, I'm going to do 4 over 12. Sorry, 6 over 12. And I'm going to multiply that by 4 over 12. And I will get 1 over 6. So my A and B is equal to 1 over 6. So then if I use that rule of 6 on 12 plus 4 on 12, take away 1 on 6, and I've got that in my calculator, that gives me, and I'll change that to the fraction, I get 2 over 3, which was what I worked out from my Venn diagram. So I can use it both ways. In this case, it's probably easier to do it in the Venn diagram form, but the next two I'm going to look at are obviously can't do my Venn, like it's more difficult to use the Venn diagram, easier just to use the rule. So here we've been given that the probability of A is 0.5, the probability of B is 0.4, and the probability of A and B is 0.2. So if I want probability of A or B, I've got my 0.5 plus my 0.4, and I'm going to take away 0.2. So 0.5 plus 0.4 is 0.9, take away 0.2 is 0.7. And we could set up that Venn diagram and work that out, but it's easier just to use the rule. The next one here is a little bit more complicated version of it. So we've got the probability of A, so we'll set up our probability of A union B is equal to probability of A plus the probability of B minus the probability of A and B. So in this case, we've got the probability of A union B, which is 0.5. We've got the probability of A is 0.3. The probability of B is 0.4. And we don't know the probability of A and B. So I'm going to give that an X. So then we need to solve for X. So 0.3 plus 0.4 is 0.7. So we say, what do we take away from 0.7 that's going to give us 0.5? So X must be equal to 0.2. So that one is a little bit different, like a more complicated version than the previous one, but still okay to do. And again, you could set up your Venn diagram for that as well. Hopefully that helps you with your addition rule.